Hi. So today's talk is about really underrated two services. Actually, one service and one policy feature. So we will be talking about AWS SSM and attribute-based access controls. So by the end of this presentation, I hope I'll be able to show you the better way how to manage VPN in your organizations. And I'll show you two solutions. Actually, it's one solution, but with two different, let's say, options. Both using the AWS SSM, both are zero trust, and both are simpler than probably what you have today. So, yeah. My name is Serhii Kaidalov. I'm community builder, Gold Coast user group co-organizer, Ukrainian, moved to Australia just a couple of months ago. A couple of interesting facts also about me. And if you want to connect, here is the LinkedIn QR code.
Done.
Cool. So, what, you want QR code? Or something?
Someone tried. Yeah,
I can share it if you need it.
$20.
All good? Cool.
I'm already connected.
Cool. Since I said I'm Gold Coast User Group organizer, we're also looking for speakers. Don't hesitate to scan this QR code as well. This is the link to the sessionize. And yeah, if you want to speak, you have something to present. And don't want to speak on the AWS community day, because there will be a lot of people. We have much smaller community, so you can train. And yeah, please scan it, and we are welcome.
You can speak about user group. You can stay here and you will close.
Yeah, exactly. Yep. So here is the agenda. So we will start with the problem with VPN. Not necessarily the problem, but what VPN doesn't solve and what SSM is try to solve and solves. I'll show you the first solution. Then we will have a short live demo, not on the solution, but on the attribute-based access controls. Then we will have a problem which first solution doesn't solve, and solution number two. And then which pattern we will be using. I'll show you which pattern to use and when. Yeah, so show of hands, who was using the corporate VPN this week? Yeah, right, a couple of people, good. So that is the usual setup. You have your laptop, PC, machine, doesn't matter. You have VPN client, you connect to the VPN gateway, and boom, you are in the your private environment, your AWS network, and that is bad. So once you connect it, you can reach the whole network. Yeah, you can agree. You can argue with me that there are solutions like Palo Alto, for example, which allows you to put a policy on a single user and prohibit accessing some parts of your network, but they're expensive, obviously. And VPN, as I said, give you too much. So you can access any host. You can say, from the audit perspective, where this user connected afterwards. So you can say only the user is connected to the VPN at this time, and afterwards it's hard to tell where it went. Then you still need to manage SSH keys, DB password, shared credentials. I'll explain later why those points are there. And again, laptop is inside your trust boundary. And that's the problem. So if your laptop is compromised, basically, attacker can access the whole your infrastructure, and that is bad. And yep, that's basically the shift. And you should stop asking yourself, are you on the VPN? And start asking, are you authorized to access this resource right now? Let's check the first pattern. So actually, both patterns look exactly the same, almost. There are a couple of differences. So you have your developer laptop, your user laptop, doesn't matter. You authorize with SSO, you have MPA there. And even if you don't use the SSO for some reason, it still applies if you just have your regular users. You can still apply the same. Then you have, with SSO, you have IAM Identity Center, which injects the username tag into the user session. I'll explain later how it works with the usual user, but let's say we have this session, we have username tag, then we have single IAM role with attribute-based access control policies. And we have like 3 gates here. You can have more, doesn't matter. And then you have Bastion EC2 instance inside your private subnet without any internet access. Instance has no any open ports whatsoever. It only allowed to talk to SSM via VPC endpoint. And from that instance, we establish port forwarding session to our selected resource. It can be database, it can be something else, it can be another EC2 instance. Doesn't really matter. It's secure, and you have connection. Like your laptop only sees open ports on your local host. That's it. No any access directly to your infrastructure, only to certain resource, to certain port. That's the most important slide of this solution, basically. So you have the SSO Identity Center, which injects this tag, and you can use it later by referencing in policy like AWS principal tag username. I hope it's clear. Okay. Without SSO, you can still use the same. You have variable which you can use in policy. It's called AWS : username. And those 2 variables you can use in your policies. For example, in start session, you allow only to access document with name which equals to your username, basically. Then you can use the same with S3. You can use the same with RDS. So it really scales. And you have only one policy. You don't need to create policies for each user, for each role. You have single policy, and basically tags do the job. The guardrails, what we can put, exactly what I said. So, for example, our instance has the tag SSM bastion equals true. If we allow that in policy, we are able to connect only to that instance. Then the same with document. If our document matches that exact name with our username, we able to start session. And by this AWS user ID, we can control, we can limit the user to terminate and start only his own sessions. And let's look at the SSM document, how it looks like. That's the example of the SSM document, which gives us ability to do port forwarding. We have here allowed pattern. So this document allows to start port forwarding session to port number 3306 and to specific host. In this case, we have this asterisk here, but you can specify exact host name. So it will be single database instance with the single port. So port locked to 3306. Host name is also locked, and the policy and the document itself name it like this. And only this specific user, for example, my name is Serhii Kaidalov, that goes through the SSO, and the document will be named port forwarding dash Serhii Kaidalov dash RDS dash 3306. That's basically payoffs. Additional benefits, as I said. If you're using the AWS RDS, RDS supports IAM house authentication. And by using those tags, you can grant users access to RDS. And instead of each user has its own password, which you need to rotate, manage, with this, each user can generate 50 minutes token. And after 15 minutes, the token is expired. You don't need to manage passwords. You don't need to rotate them. Everything's clear. For S3 buckets, for example, you have a lot of developers. They need to store something on S3, just an example. And instead of creating a lot of S3 buckets, limit those buckets for each developer, you can do it per prefix. So you can have single bucket, single policy for your role, and each developer will be able to access only his prefix inside of this bucket. And it really scales. You can use it with KMS, secret manager, parameter store, anywhere where you can put this principal tag in the policy. Hardening checklist. So you can have it even more secure. So for example, as I said, your VPN is bad, but not necessarily bad. You can just need to put it out inside of your environment. And then if you use organization, you can apply the SCP and allow opening session only from your VPN IP. In that case, if your VPN is compromised, nothing happens. You still need to have AWS credentials. If your AWS credentials leaked, you are not able to start the session because you still need to be connected to that VPN instance. But that VPN instance is not inside your environment. Then session. So you can limit the idle timeout of each session, for example, for 2 minutes. And if user doesn't type anything in this session, performance session, it will be terminated after 2 minutes. You can delimit the session length, for example, 1 hour. So if it's open, you're doing something but you don't want, like, for security regulation, something else, you need to limit the session only for 1 hour. You can do that. You can have stream logs in the session. You can put them in a S3 bucket or in CloudWatch, so you can have full transparency what user type in that session, but that doesn't work with port forwarding. That works with the solution number 2. And also, you have clear visibility in CloudTrail, which user connected when, and then what it did in the session, which resource he accessed it, etc., etc. Let's see attribute-based access control in action. So before the demo, so what we will do, we will have a couple of resources with tag environment equals production. So we will have user without SSO, just a regular user. User has this tag. Our instance has this tag. Our SSM document also has the same set of tags. I'll show you the policy. I'll show you all the tags on all resources. And then we will establish a connection. We will have the access. Then we will check the tag on the instance. And I'll show you that access will be denied. So let's dive into the demo. Where is our demo? Yep. Yep. So let's review the policy that's attached to the user. So the policy looks like this. As you can see, we allow to start session to any instance, and tag on the instance, like value of this tag, should equals the same value on our user tag. The same goes to the SSM document. The same, everything goes here. For example, as I said, we allow only terminate and resume our own sessions. So let's check tags on our demo user. As you can see, user has the single tag, environment, and value equals to production. Let's check tag on our instance. Yeah, it's not like demo. It's pre-recorded. So. Yeah, so on the EC2 instance, we have 2 tags, name demo EC2, and environment equals production. Let's check the SSM document. SSM document has the same set of tags, basically. And let's start the session. That's the command. So we're using SSM. We start the session to that instance and using our document name. And we are able to connect. We can type some commands on the instance, like who am I, IP address. So connection works. And as you can see, we're using the SSM user. It's shared user. And I explain why it's bad for certain environments later. Let's change the tag on the EC2 instance. So we're changing the tag environment. It was production. Now we're changing it to the development. And let's execute the same exact command. And as you expect, it's denied. Yep, that's the whole demo. And exactly what happened. So we didn't change any firewall rules. We didn't change the policy. We changed only the single tag, and access is denied. And we can say who connected to this RJS yesterday. One CloudTrail query. But why it's bad? Because, for example, in certain companies, you have like highly regulated environments. It could be healthcare, it could be payments. And if you use port forwarding, because tunnel terminates on your laptop and goes straight into your environment production, like data card holder, healthcare, something else. And by PCI, you put your laptop in scope. Because, for example, card holder data environment can leak to your laptop and then go somewhere else. You will not pass the PCI with that. But we can solve this problem with solution number 2. So what are gaps here before we go to the solution? So we need individual accountability. So every session needs to be a named person. With port forwarding, we're using the shared user, SSM user. And for the command level audit, exactly, port forwarding doesn't allow you to do that. When you open the session to the bastion instance, like shell session, you can have all the common audits inside of the, like in the logs. Then data, again, it should stay in the cardholder environment. Let me show you the solution. It may look the same, but instead of port forwarding, we establish the SSH session. Yes, it's talking about only Linux machines. Luckily, our client didn't have Windows, but if you also can do that with Windows machine using SSM. The only problem with this solution, all your users should be present on the instance, because in this solution, SSM opens session as you named user. I will show you how. So we will using a slightly different SSM document, and we need to put this parameter inside of the document. This parameter called run as enabled equals true, and with this, SSM tries to switch user from SSM to your user, which is specified in the text SSM session run as. Again, that tag you can inject into the session. If you're using SSO, you can put, if you don't use SSO, you can attach it to user directly. And then if user doesn't exist on the instance, access will be denied. That's why you need to have some sort of Active Directory or LDAP. If you're using like big corporation, that's what you already have. If you like a small, and you have like small set of users, you can provision those users directly on the instance, if it makes sense. So that is the differences between two solutions. So first one expands your laptop into the PCI scope or in any audit scope. The second one is not. Second gives you interactive shell, gives you command level audit, and the only downside of that solution, you need to have some kind of user management, additional user management, in like an Active Directory, LDAP, or provision that account by yourself. Again, best for dev, UAT, everything that is not highly regulated. If you were to remember only single slide, remember this. So you can use port forwarding when you have dev, when you need exact access to a single instance, single port, and the second solution when you in PCI scope, for example. What is next? I show you the two solutions, but again, in big corporations, it's not really great to manage all these documents by yourself. Because with port forwarding, the idea is every user has specific document for the specific resource and specific port. So that repo has kind of proof of concept, which written with the help of AI. Yeah, I believe you all gathered here about AI, so I'm delivering the AI to you today. Yeah, so how it works. So basically, it relies on the Slack. Unfortunately, on the paid Slack subscription, because it uses Slack groups. So every user in your organization can type this SSM access. It will be having the drop-down menu, like I want to access this host with this port for this amount of time, and that is the reason. Then that request will be forwarded to two groups. In our case, it was two groups. One group is security. The second group is your line manager. So when you have two approves, your access will be provided. So bot will go to the AWS environment, create this document with these specific parameters that was specified, and will give you in Slack the message like, here is your connection URL, you can use it, and after the time is done, it will remove that document and you will not have access to that resource anymore. That's all. Thank you. Hope it was useful. And you can, again, this is the QR code for LinkedIn, and if you want to dive deep into the both solution, there are two articles. Article part 1, that's exactly port forwarding solution. Part 2 is the shell solution. There are more details. They are in more like code examples, more details. Everything's there. Thank you. Any questions? Yes.
Based on this solution, it's very clear that you're attaching the session ID out of the box, right, to AWS. And then you have a assume role principal tag, which is careful. Now, what you will observe is in multi-role, cross-role, multi-position architectures, large organizations, you will find that when the multitude of assume role functions will fire, the tags will get dropped. So, how do you make sure in this architecture that the principal tag will still continue its validity downstream trust policies without complicating it? Because downstream has to play a role when I go across. How do we make sure this?
That's a good question. In this case, you don't need to do that.
Right. How does it manage then? Because my downstream trust policies have to still allow for the role to assume.
You don't. That solution only works for accessing the SSM. Then you don't need the tag anymore.
Okay.
So you have access to the RDS. Then you can you're using still the same role, and you can access the RDS.
Right. So once you get into the SSM, would you rely still on your source identity, or you would rely on tags and your pre-configured trust policy?
So with this solution, which one? Port forwarding or shell instance?
Shell instance.
So
because port forwarding you can't do PCM.
yeah. So, oops. Okay. So you open the shell, and then from the inside of the instance, you can assume any other role. But with this, the solution is done. So you access to the instance, and then you need to assume any other roles to.
After that.
Yeah, but
okay.
That's a completely different story. So you can use your own, you can use this original role to get the token, for example, for the database, but that will be the single role. It's not it's not continuous from the SSM instance. You need to generate token and then copy paste it to the instance via the terminal or something. So instance doesn't have any roles, any policies.
Cool. Thank you.
Thank you.